Hello people, welcome back. And in today's session, we are going to talk about the p-value or the probability value. Let's understand first the definition of the probability value and then we'll take an example of that. So the p-value is an statistical measure used in hypothesis testing. Last session, I explained you about the hypothesis testing. So p-value is an statistical measure which is used in hypothesis testing to determine the probability of obtaining result at least as extreme as observed result, assuming that the null hypothesis is true. So p-value is a probability value, and the probability of any event will happen is maximum 100% and minimum 0%. So basically, the probability value ranges from 0 to 100% or 0 to 1. So the p-value is a number between 0 and 1 that represent the strength of evidence against the null hypothesis. So how strongly you are accepting or rejecting the null hypothesis or alternate hypothesis, that will depend on what is the p-value you are getting on a scale of 0 to 1. So p-value is less than or equal to the chosen significance level. Typically, we use significance level as a 95%. So 95%, 100% minus 95% is 5%. 5% can be represented on a scale of 0 to 1 as in 0.05. So that's become your threshold. So it is considered the significance level, and the null hypothesis is rejected in favor of the alternate hypothesis. So p-value is not a measure of size of an effect or the importance of a result, but it's a assess the strength of evidence against the null hypothesis, how strongly you are rejecting the null hypothesis or you are failed to reject the null hypothesis. P-value is influenced by the factor, how much your sample size, what is the effect size, what is the variability in the data. And it's really important to interpret the p-value in conjunction with the other factor like as sample size and the what kind of question you are trying to prove or the hypothesis you are trying to prove. The calculation of the p-value will depend on the specific statistical test being used. Different tests have different formulas and approach of calculating p-value. So as per the test, we'll be deciding which formula we are going to use as per the test, as per the sample size, as per the context we are trying to prove, what we are comparing, either the mean we are comparing, median we are comparing, variation we are comparing, defect rate, defective rate, and so many things. Based on that, we will be deciding the formula, and accordingly we'll calculate the statistics, and according to statistics we'll be looking for the probability value of that. So it is recommended to consult statistical software, maybe Minitab, GMP, Statisia, or any other, specific to the test that you are going to obtain the accurate p-value. So now let's understand the importance of p-value. We have two things in our business whenever we are taking any business decision. So one thing, you are comparing the statistical data. Maybe you are comparing with the target, one value with the target. Maybe you are comparing two data sets with each other. Maybe you are comparing more than two data sets with each other. So you are looking for the relationship. What is the strength of relationship? And either it's a significantly related or not. So the level of significance, if I take confidence level of any statistical analysis, is 95%. So then there is a chance of error will be around 100% minus 95%, which is 5% are the chance of error. This 5%, if I convert into the simple numbers, so if I say 5% and I convert into the number, that can be your 0.05. This is what the level of significance, right? So this is 0.05 is here. That's what the p-value, generally the level of significance we consider as in 0.05. Understand an example. Here, suppose your target let's say quality or target production, anything you take, which is you are looking for practically to achieve, is let's say 90. And maybe when you are validating this 90 with the observation or the sample data you have collected, and you are comparing target with the observation, and your p-value for this is coming around, let's say, less than 0.05. So in this case, we will say there is a difference in the target and the actual observation. Statistically, they are significantly different. If your target is 90 and your probability value comes greater than 0.05, then statistically they are same. So here we will say different. Here we will say same. Why? Because if the p-value is less than 0.05, it's an alternate hypothesis, which always say there is a difference. And if the p-value is greater than 0.05, then it's a null hypothesis, and we will say they are same. That's about the p-value, and you will be learning about the more about the p-value in the upcoming session when I'll explain each and every statistical test with respect to the p-value and the interpretation. Thank you so much, people. I'll see you in the next session.